In data analytics, machine learning, AI, one of the libraries that you might find useful is NumPy. NumPy is great for dealing with vectors and linear algebra. For instance, let's say you're dealing with some sort of machine learning project where you want to store data this way. We have a feature vector. Let's say we have age and height. We're going to use this feature vector to predict how many books someone reads a month. And we can even store this label or the desired output as a vector. So as you can see, everything here is stored as a vector, and it's all composed within a data point or list. So the first thing when dealing with NumPy is you have to import NumPy. Well, prior to that, you'd have to install NumPy, but once you have it installed, you can import it. So you can import NumPy as NP, which means whenever we want to use anything in NumPy, we reference it as NP. Let's start by creating a vector. Again, we write np dot, and we use this function array. And this takes in a list. Let's just say we do, we'll stick to this example. The person's age can be 31, and their height, we'll say, is 180 centimeters. Okay. Let's give this vector a name. I'll call it feature vector 1. So we could have many different feature vectors. Okay. Now let's print this feature vector out and see what it looks like. So print feature vector 1. And you get 31, 180. So this is a row vector, right? All the numbers, all the elements are along the same row. We wanted our vector to be a column vector. It has 2 rows and 1 column. What we can do is just reshape the vector. So I can say feature, well, I'll do it right here. We could say feature vector 1 equals whatever feature vector 1 is right now. So feature vector 1 dot reshape. And instead, we want to have 2 rows and 1 column, right? 2 rows, 1 column. And now if we print our feature vector out, we can see it looks to be in the same format that we intended. Okay, so you can use the reshape function. Now, if we already have a vector created and we want to get the dimensions, well, we can display that. So we can print, let's say we're going to look at feature vector 1. We write dot shape. Shape is a property. If we run that, we get 2, 1. That means 2 rows and 1 column. If we just want the number of rows, that's the first element in our tuple, so we can index it at 0. It's the 0th element, technically. And we get 2 rows. If we want just the number of columns in our vector, we can get the first element, and there's 1 column. All right, that's getting the dimensions of a vector. If we want to access a specific element, we can do indexing. Let's say we want to print the person's age, so we'll go into our feature vector 1 and get the 0th element, right? The 0th element, which is age. And we get 31. If we want to get their height, we get 180. So you can index a vector that way. All right. Now, let's also create an output vector. Output vector, or well, I'll call it label vector 1 to stay consistent here. Label vector 1 equals, again, np.array. Now, in our case, our label is just a one-dimensional vector. It just has 1 element within it. So that's easy. Let's say this person has, they read 5 books a month. Okay, so label vector 1. Now we can create a data point like this by just constructing a tuple. So I can call this data point 1, and the first element is going to be the feature vector 1. And the second element is going to be the label vector 1, like that. So we have a data point, and we can even create a whole data set, and it can be a list. We'll start it as an empty list, and then we can say data set dot append our data point 1. Right, so we can start constructing a data set. If we want to do it, by hand, I suppose we could keep adding data points this way. Now, when dealing with vectors, we want to be able to perform operations. because ultimately we're going to kind of be designing models where we can take our feature vector, manipulate it in different ways to produce some desired output. So we need to know how to manipulate vectors. So to demonstrate this, let's just create two new vectors. So vector1 equals np.array. Let's just say we do 1, 2. I'm going to reshape it right away to make it a column vector as we did previously. So I'll reshape it to have 2 rows and 1 column. Let's create a vector 2. Same process. I'll give it some different elements, same dimensions though. Let's say 3 and 4. We'll dot reshape that to have 2 columns, 1 row. What happens if we add a constant to one of these vectors? Let's take vector 1, which is the vector 1, 2, and we'll add 1. We get 2, 3. So recall, vector 1 was originally 1, 2, now it's 2, 3. So the 1 gets added to each element, and we call such an operation an element-wise operator. It affects all the elements. How about if we add 2 vectors? Well, let's add our vector 1 to our vector 2. Let's get rid of this for now. And we get 4, 6, right? 1 plus 3 is 4, and 2 plus 4 is 6. It adds the corresponding elements. And if you're familiar with vectors, linear algebra, even physics, you would know that when you're doing vector addition, you add the corresponding components. Now, with multiplying a vector by a constant, let's take vector 1 again, which is 1, 2, and we'll multiply it by 3. And we get 3, 6. And it was originally 1, 2. So again, multiplying by a constant is a element-wise operator. It gets applied to both elements. So we're multiplying 3 by both elements. How about if we multiply 2 vectors? Well, we can say take vector 1 and multiply it by vector 2. We get 3, 8. It did 1 times 3 to get 3, and then 2 times 4 to get 8. So it multiplied the corresponding components. Okay, we'll leave that out for now. Now what if you want to make like a custom element-wise function? So I can define a new function. Let's just call it foo for now. It's going to take in just one number. And let's say it returns, 2 to the power of whatever the input was, minus 2, let's say. So we can define it however we want. I want to turn this, right now it just takes in a single number. I want to vectorize this so that it applies to all the elements if I put a vector as the input. So what I can do is I can say foo equals np.vectorize. I put the function in here, so foo, and that vectorizes the function. So now if I print, for instance, the foo of, let's say, vector 1, okay, it applies foo to each element. So originally for vector 1, my first element was 1, so it did 2 to the power of 1, which is 2, minus 2, which is 0. The second element was 2, so it did 2 to the power of 2, which is 4, and minus 2, and gave me 2. So you can create a function that applies to each element, an element-wise function, that way. You just have to vectorize it. All right? So those are some of the basics of NumPy.